So here's an example of using the work equation. A labourer moves a 25 kilogram haystack from one diagonal to another on a 300 by 400 metre farm. He applies a constant force of 200 newtons on the hay. Calculate the work done by them. So if you remember, work is force times displacement. So with that, I recommend you give it a try and come back and see the solution. So here's the solution. We have a 300 by 400 metre farm and he goes through the diagonal. So it's a simple Pythagoras' theorem. So s squared is 300 squared plus 400 squared, which means s is 500 meters. So from here to there is 500 meters. Then we have the force is 200 newtons, the displacement is 500 meters. So work is force times displacement. So 200 by 500 is 100,000 joules, which is the unit for work in energy. So any sort of energy is given the unit of joules. It's said in the previous slide. I'm just reassuring. This can also be written simply as 100 kilojoules, which is another fairly common unit of energy. Dimensionally, you can also write this as 100,000 Newton meters. But Newton meters we'll come to know as something slightly different when we get onto rigid bodies.